Welcome to Math Dive in 5 for Grade 3. This is Unit 8 on numerical patterns. My name is Daryl Frost.
And I'm Barbara Knox.
On the next slide, you're going to pause the video, complete the task on the next slide on your own or with a team or with your team or partner. Solve the problem, create a model using a manipulative of your choice and label it. Create a table based on the model. Describe the table and model with a pattern. As you are working through the task, write 2 questions that you could use to facilitate connecting your concrete model to the table. Happy problem solving.
See you back in a few minutes.
So before we actually get into that problem, I'm so excited to see all the different strategies on how they solve that problem. Let's take a look at the progression within BEST. We start in 2nd grade talking about even and odd numbers. You see highlighted within this unit 3 different AR, algebraic reasoning benchmarks, determining whether a whole number is even or odd, working with patterns, and then also determining if any number between 1 and 144 is a multiple of any given 1-digit number, like 1 through 9. And that's new to 3rd grade, right? And then from there it pairs up. It moves forward to now start talking about factors, learning about factors, and then generate, describing, and extending patterns, which is a strong connection to where we're going to be going today, because we're going to focus on, within this unit, this benchmark here, AR32, and notice the 3 skills: identify, create, and extend a numerical pattern. Right, and that's what we're going to focus on. Let's do it. So here are some questions that we developed as we were thinking through this problem, and I know that those teachers that are participating in this Math Dive in 5 came up with at least 2 to connect these 2 models, and probably many others. So let's talk about here. Tell me about that array in the upper left.
So in your model, I see that it was built with all the same color of tile, and they put them into an array. So each row in your array represents a bracelet, and there are 4 things, which are the charms, in each one of those rows, and that represents the rows. If you look at the table, Daryl, my model looks a little bit different. I have groups instead of an array. A student could have even done a number line instead of an array with jumps of 4. And what else do you notice that's different about my model?
You used different colors to represent each of the seasons in the problem.
Exactly. So I have 4 different colors, one for spring, fall, winter, and summer, and you can see all 4 seasons in each one of my models.
That's a way to scaffold.
It is.
Because this could be a little more abstract for a child who, I need to see, there's 4 seasons, where are they? Right. I don't see them here. Many could, but that's a way to scaffold it
so then connect. I'm also kind of comparing our tables, because your table looks a little bit different than mine. You started with 40 charms.
I did.
And each time you took 4 charms from that group of 40, and that left you with 36. You took another 4, it left you with 32. So I can kind of sense the repeated subtraction in yours, where my table starts with 4. So I started with 1 bracelet, takes 4 charms.
Okay.
2 bracelets takes 8 charms. 3 bracelets takes 12 charms.
So you thought about it like with multiplication.
Exactly. And I can look at your table and my table, and if I'm sharing those in the classroom, I can help students make connections between the multiplication and division that I see in each one of these models.
Yeah, how were they connected? How's, one thought about multiplication, one thought about, I started for the total, for me, with the division.
You did.
And you just started with 4, you knew that 4 charms made a bracelet, and you just began from there. That was what was in your head.
I was thinking about multiplying to divide.
multiply to divide, going up to 40
Yes.
charms.
And you started with the 40 and started removing your charms.
All right, and so these are things that we want students to think about, and this is how, you can help students build a model to make sense of the table, compare and contrast, because third graders at this point are going to use a lot of strategies.
Yes, they are.
To, solve multiplication or division problems, and they're applying that here in this AR benchmark.
And you and I, we definitely don't want to get into the rut of kind of expecting the same thing from all of our students. We want to give them the freedom to build different models and then make connections between each of those models.
That's how we deepen the understanding.
That's right.
So here are 4 potential misconceptions that you might have with this benchmark on patterning. When determining numbers within a pattern, students might repeat the numbers listed thus far instead of expanding the pattern. One way to address that is what you just saw, and what you did with the charms problem was create models. They need tools to be working with these tables to make sense of them, and eventually get to where they can just look at a table, but they need those concrete experiences.
So if I'm thinking about the charms, a student could have put 4, 4, 4, 4, 4 across their table, just thinking about the 4s that they were taking away from that group of 40. But we want them to see, when I take one group of 4 away, how many are left in my total group of charms.
And what is that group creating? It's creating a bracelet in this sense. Yes.
The next one, they're falsely identifying the rule of a pattern because they base that pattern on the first few numbers. Sometimes a rule -4 might work, but if I take it to the next level, -4 doesn't work. So we can't just look at the first set of bracelets and charms. We have to look at all of them to make sure that the rule works for all of the different sets in our
because if I'm just looking at 40 take away 4 is 36 charms left, but that's not going to work after that. Or right? Are we saying that?
Well, it will work if I'm going across, but I mean, if I look at 40 and 10, 40 take away 30 is 10.
Gotcha.
But if I go to 36 and 9, 36 take away 30 isn't 9.
Gotcha.
Right. So that rule of take away 30 doesn't work there. But if I divide by 4, it works every time.
But it's the relationship between the charms and the bracelets is the pattern.
Not from charms to charms.
Exactly. The confusion on how to set up or read tables, I think we just talked about that there.
You really need the concrete tools in order for them to understand how a table is set up. If they've not had experience with tables before, doing a problem like this charms and bracelets problem will help them to understand what goes in each section of that table.
And the confusion on the operations, well, quite honestly, we used several operations. We used addition. I used repeated subtraction.
Yes. And
connected that to division.
I really used repeated addition to get to that 40, which is also connected to the multiplication. So we could have used any of the 4 operations, and we want to make sure that students get to an efficient strategy using the most efficient operation in the end. But we also want them to see connections between all of the operations and how they can work together.
Exactly. We thank you for joining us for this Math Dive in 5 on numerical patterns.
We'll see you back next time.
Bye.
Bye.